welcome to our webinar, OpenSource Security 101. My name is Paul Curran, and I will be today's moderator. Before we get started, I'd like to go over a few items so that you know how to participate in today's event. You will have the opportunity to submit text questions to our presenters by typing your questions into the questions pane of your webinar control panel. You may send in questions at any time during the presentation. We will collect these questions and address them during our Q&A session at the end of today's presentation. During today's webinar, you will hear from two speakers, Rami Sas and Matt Rose. Rami Sas is an entrepreneur with many years of experience in cybersecurity R&D and product management. Rami is the CEO and co-founder of WhiteSource, the open source security and license management solution, which allows engineering and security executives to effortlessly manage the use of open source components in their software, thus allowing developers to focus on building great products. Rami helps CSOs, CISOs, CTOs, VPs, and heads of engineering effortlessly manage their usage of open source components and frameworks. Matt Rose is the Director of Application Security Strategy at Checkmarx. Matt has over 18 years of software development, sales engineering management, and consulting experience. During this time, Matt has helped some of the largest organizations in the world in a variety of industries, regions, and technical environments implement secure software development lifecycles utilizing static analysis. Matt's extensive background in application security has been key to many speaking engagements for organizations such as OWASP, ISA, and ISACA. Over to you, Rami.
Okay, so thank you very much for that warm introduction. In today's session, I will try and provide a high-level overview of the sort of considerations that engineering teams and security officers should keep in mind when tackling open source and open source security issues, as this issue is becoming more and more prevalent as engineers, software engineers throughout any type of organization keep adopting more and more open source components and embedding them into the software that they produce and then sell commercially. As some of you probably already know without resorting to Gartner for research, software engineers rely very heavily on open source. And in fact, there's actually a very well-known saying by Mark Anderson about how software is eating the world. The fact is that open source is eating the software world, and in any given commercial application, a larger and larger portion of that application will be comprised out of open source when it gets shipped out and installed on customers' premises. Right. Generally speaking, when you look at a commercial application, that application is comprised out of parts which come from different sources. One is the core competence proprietary code that the engineers develop themselves and test and do a lot of work in order to maintain. The other are commercial components that are bought off the shelf and incorporated into the software. And last, but definitely not least, are the open source components that are publicly available and are taken by those same engineers and embedded into their software. So how should you go about detecting vulnerabilities, security vulnerabilities in those different parts of your application? So for proprietary code, you would use SAST and DAST scanners in order to analyze the code that the developers write themselves and try to figure out if there are any potentially hazardous patterns in the code and report on those. That's certainly not the case with open source components. For open source components, it's a completely different picture where you would need some other methodology, normally an automated tool, to discover the already known and well-established vulnerabilities that have been reported out there in the world and are publicly available as well, and be able to mitigate them normally by upgrading to a different version or acting out some other activity that is very different than what you would do with your own proprietary code. So if we look more closely at the differences between the vulnerabilities that may come up where developers write code and may have bugs in their code that can potentially escalate into security breaches, and what goes on in the open source community. And this is now completely from the perspective of the engineering team and the people who develop software and consume open source components and then have to ship out their software, their application to their customers, right? That's the perspective that we are trying to explore here. From that perspective, there are many different ways in which proprietary vulnerabilities and open source vulnerabilities differ. First, and I would even say foremost, is how you would even go about detecting that a vulnerability exists. So in proprietary code, you would do, as mentioned earlier, some sort of analysis on the code in order to detect patterns that seem out of what your definition is or out of some predefined set of roles. But in the open source world, there's no point in doing that. And furthermore, there's actually already public repositories where vulnerabilities are reported and verified, and often suggested fixes are also available, which are much more easy to find and fix than trying to scan the code yourself. In terms of publication, there is no publicly available information about the code that you write because you don't release it to the public and you don't let anyone else inspect it for you. And with open source, the opposite is correct, where the open source is itself publicly available and all reported vulnerabilities are also made public, and the fixes are publicly available and so on. So the visibility of the two is very different. For remediation in your own code, you will have to take steps in order to rectify your own code and test it and verify and make sure that the bug is gone. But for open source components, that's not a good practice because normally the open source community has done all of those actions for you and has, in a very large majority of the cases, already rolled out a patch or a newer version that can remediate the security issue, and normally is actually easier to implement than trying to download the code and try and fix the bug yourself. In terms of when you are looking for these vulnerabilities, so scanning and analyzing your own code, you can do once per version because the vulnerabilities will not change. For open source, it's more complicated than that for a few reasons. One, the actual components may change or may be different between installations. And two, which is actually more important, new vulnerabilities may be discovered in the future, sometimes even after the product is deployed on customer side, that you would want to know about, because sometimes there are still actions to take, some maybe just by upgrading your operating system or something like that, you can still mitigate those vulnerabilities even in production. So in open source, there's a lot of benefit in continuously monitoring for vulnerabilities and mitigating them throughout the development lifecycle and also after deployment. Okay. And finally, your proprietary code is just code, where open source may come in code format, but also normally, depending on the language, can also be distributed in binary form, which makes it actually impervious to code static analysis, right? You cannot scan binary component for its code. So that's not even practical in that respect. So what's actually safer when you are a software engineer and you need to choose between a commercial component or an open source component? There are always considerations for one or the other. One would claim that the proprietary software has SLAs and people who get paid in order to make sure it is secure and properly maintained. And then others will claim that open source projects have a much broader reach, a stronger community, much more eyeballs looking at it, which in turn can give it a stronger backbone and better maintainability or better maintenance, which would make it more robust and less vulnerable. I'm not here to give you a ruling on this debate. Just let you know that it's out there, but there are, I know, many people who would consider open source to be safer because of the reasons I mentioned. In any event, it's probably very different between different projects of open source. So some that have strong and active communities will be better maintained and less vulnerable, whereas smaller projects don't have a lot of activity with their community will be more vulnerable to security issues. So how does that even work? How do open source vulnerabilities get discovered and reported, and where does that happen? So generally speaking, there are two types of people that can find vulnerabilities in an open source project. One would be people who develop the project themselves or contribute to it, and as part of their work on that open source project, will find security vulnerabilities in the same way that they may find other types of bugs or issues or functionality that's missing with their project or with the project that they are contributing to or working on. And then they may report that issue to either MITRE, which is the organization that produces what's called a CVE, that's a common vulnerability enumeration, which we'll talk about in a second, or they may not even know about MITRE and CVEs or not care about them and simply report that a vulnerability in their own publicly available bug tracker or their favorite security advisory that they may know and like, sort of in an unmanaged, unmonitored kind of fashion. So that goes for how the people who work on the open source projects themselves find and report on vulnerabilities. The other type of individuals that may find vulnerabilities in open source components are dedicated security researchers. And these may be people who are hired explicitly in order to find vulnerabilities in those open source projects or for some other security related project, and then would find these vulnerabilities as a side effect of their main project. In any event, these guys being sort of more dedicated and professional in the security space would normally be more minded to put out a report in MITRE in the form of a CVE, as well as notify the people who work on the open source project to make sure that they are working on a fix and that they also contribute to the knowledge base about that vulnerability. So once the organization called MITRE here gets a report about a newly discovered vulnerability, they would go about vetting it themselves, making sure it's not noise or some random bug or something that's not supposed to be reported to the public. Make sure that the people who are in charge of the open source project are aware of this issue and are taking steps in order to remediate it. Then give them a grace period of a couple of months normally in order to fix that issue and roll out a newer version and let their community members know that there's a new version out there and that they are supposed to go out and upgrade to block that vulnerability and make sure they are not exposed. And at that point in time, they will publicly release that information, almost always along with the suggestion of how to fix it, or at least some sort of remediation path to help people and not just tell them that the vulnerability is out there. And at this point, they would push that information into NVD, which is the National Vulnerabilities Database, which is actually maintained by NIST, the National Institute for Standards and Technology, that's funded by the US government. And those guys, within 3, 4, 5 business days, would run some tests independently to see how exploitable the vulnerability is, because sometimes vulnerabilities may exist in the code, but not really be exploitable, or not be exploitable in some scenarios or in some operating systems or some environments. So that's the sort of test that the NVD do, and then provide that information back to the public as well. So all of that is very good, and indeed NVD is a very prominent source, a very good one, and solid source for vulnerabilities. And by the way, the majority of vulnerabilities reported on NVD have nothing to do with open source. It's an organization that also tracks commercial software and operating system, and over 90% of the vulnerabilities reported in that database are for commercial software and not for open source components. But still, they would also talk about open source vulnerabilities, which is great. But besides them, if you remember those open source project guys who may not report to NVD, they have their own other security advisories or bug trackers that they use, and may report on vulnerabilities there that may, one, never even make it to NVD, or two, make it after that grace period and after that extra testing and vetting that the NVD does, which means that you can find vulnerabilities in those advisories and bug trackers 2, 3, 4 months before they make it to NVD. And you, as a software engineer or someone that's working to release software, have an interest to find these issues as early as possible in your process and fix them, rather than finding out about them 4 months down the road where they are already very publicly available. So now let's talk a little bit about what these vulnerabilities can do, or some of them who have been made more publicly known. So maybe some of you have seen these logos before, or heard these names. These are the most famous open source related vulnerabilities that have been discovered over the last couple of years. I think primarily the name Hardbleed has sort of made waves in mainstream media, and also Shellshock, and some of these others, maybe to a lesser extent. You can see here Stage Fright and Poodle and Quadroot and Ghost. These all were well known enough to get their own little cartoon logo, but on an average year, there are about 5,000 other open source related security vulnerabilities that are not celebrities and do not make headlines, but can still have a very negative impact on the software that you develop and ship out, and still need to be tracked and protected against. So all of these vulnerabilities, these thousands and thousands of vulnerabilities, are publicly available. They have high visibility, and malicious people and people who want to harm you, maybe target you specifically, would also know about them and can then take advantage of these vulnerabilities and exploit them in order to cause you harm or to take some sensitive information from your own systems that you are developing. So that's something to keep in mind as well, that As opposed to proprietary vulnerabilities, open source vulnerabilities have a much higher profile, are much more visible, and are more exploitable in the sense that hackers are well aware of them and look for ways to take advantage of them. So let's quickly recap on what we've talked about so far. I like to think of it as sort of a good news, bad news situation, where the good news is that the open source community is usually very responsible and very proactive and quick to find vulnerabilities and then make serious efforts to fix them and remediate and push out new versions to their community and to the broader community of their users. And they're good at it as a whole. The bad news is that the consumers of that open source, all the software engineers distributed in their own teams and own companies, are very late to learn about these vulnerabilities, if ever. So generally speaking, there is a large disconnect between all of that good work done in the open source community and what the end users end up learning about or knowing that's going on with the open source components that they are themselves using, which sometimes they wouldn't even know what components they have or what dependencies or dependencies of the components that they have. And those components may carry vulnerabilities just the same. So by now, I think we've established that there is a problem, and if you are developing software, you should treat that as a serious security problem. But it might not be so terrible in the sense that there are good tools to handle that problem and make your lives easier around the issue of open source security. So just very quickly, let's talk about how you can go about securing your environment, your software, around the consumption that you have of open source components. So first and foremost, awareness, right? Education and training and keeping an open eye out and knowing that the issue is there and is relevant to you is key. Second, you should try and detect vulnerable components that go into your software as early in your process as possible, and then continuously throughout the development lifecycle, as well as after, where it's deployed and used by your customers. You should also keep an eye out to prioritize your vulnerabilities and see the ones that really affect you versus ones that may be publicly known but don't have anything to do with you, even though you might be using that open source component. And when you've reached the conclusion that you are vulnerable or that the exposure is relevant to you, then you should go about remediating it either by upgrading or patching or taking some other steps in order to make sure that the vulnerability is fixed. And I want to touch here on a sort of secondary consideration with open source, and that's the fact that open source components are bits of software in their own right, and in fact may have other open source dependencies themselves, which in turn can have more dependencies and so on and so forth. So in fact, when a developer adds an open source component, he may bring along a whole tree of dependencies that span from that piece of open source, which can carry their own vulnerabilities, but sort of hide under the hood doing so. So that's also something that you should keep in mind when talking about open source, is that transitivity of vulnerability throughout the tree of the components that you bring in. Okay, having said that, let's talk about the general trend in the world of DevOps that's known as shift left, which talks about basically cost structures. What it says is that finding an issue, any type of issue, could be a security issue, a bug, a design issue, whatever, earlier in your application development process has less impact on costs and resources than finding that issue later in the process. And I think that's pretty easy to understand how that makes sense, because if you, let's go back to open source here for a second, if you find a vulnerable component in the same day that the developer has downloaded it from a public repository and is considering adding it to his environment, then that's fairly easy to do. Not much ramifications there. You may just go out and find a newer version or some alternative that's not vulnerable, and you can be done within half an hour. However, if you find that same vulnerable component when you are already about to release your product to market, and you are not comfortable releasing a vulnerable component to your customers, then pulling out that component can be as painful as pulling out a tooth. Very complex, very difficult to achieve. Other pieces of the software are already dependent very heavily on that component. You've already run through QA and testing and documentation and so on. And that can incur very serious costs on engineering, as well as potentially on time to market and what your customers get and what your reputation as a software vendor may suffer from that as well. Now, let's talk a little bit about us, WhiteSource, as a company and what we can offer to sort of help and deal with all these issues we talked about. So again, we like to think as open source, of open source as being a serious effect on any step of the software development lifecycle, as you can see here in the slide, from planning through building and testing, through deployment and post-deployment maintenance in production phases. And we provide tools to help you track, monitor, comply, and potentially block or remove hazardous open source components in any one of these steps in the life cycle. And now I just very quickly want to show you some of the tools that we have for some of these steps, and I'll start with the planning phase, where we offer something that's called a selection tool, which is intended for developers while they are still just considering what open source components they want to maybe bring into their environment. So now a developer would be browsing the web using their browser, and when they would open up a page that talks about a specific open source components, we would provide with an in-context plugin that pops up in this page and requires refreshing the page in order to work, because we've been sitting here for a while now, and gives you all of the relevant information about that component in context during where the developer is doing his research on whether or not they should be using this component, and tells you all this interesting information about whether it's already being used by someone on my team, what the license is, if there are security vulnerabilities, and what my organizational policy may say about it. Let's look at another example here where there are known security vulnerabilities. So for example, here I would also get information about which vulnerabilities exist in this component, what's the overall quality rating, which goes to how well it's being maintained by the community, and if it's buggy or not, besides security and so on. Again, with all the other details that we've seen before, the licenses, the existence in other projects or in other teams, and the effect of the organizational policy on this specific component. So this is in the planning phase, supposed to give the developers a preemptive tool to see if the component that they are now considering or researching will make sense for them and will comply with the organizational policy. Besides that, we have our sort of main offering, which is a central dashboard system with many reports that give you different aspects of your open source consumption, including their security status, newer versions that are available, licensing and compliance situation, quality ranking, all of those transitive dependencies we talked about, including all the metadata around those dependencies, and so on and so forth. So actually, by hooking WhiteSource into either your build environment or repository or whatever it is that you're using, you can very easily and quickly and continuously be able to monitor and report about your open source consumption, and then stay away from potentially harmful components or components that do not comply with your policies or otherwise problematic to your organization. All right, so specifically at WhiteSource, we have a very broad coverage of programming languages. We cover basically everything that you can think of. We have a very large database for both languages that distribute open source as binary components, as well as languages that distribute open source as source files. So that would include, on the binary side, both Java and .NET and Ruby and Python and ActionScript and so on, and many different distributions of Linux and that kind of thing. And on the source side, JavaScript and PHP and C and C++ and even the Go programming language and other more obscure languages, we basically cover all of them and are able to provide information about their licensing and security situation. Besides that, we take a lot of pride in our proprietary matching algorithms that give you a very high accuracy when matching vulnerabilities to specific open source components. And we do this matching not just from NVD, but from a plethora of other security advisories and publicly available sources about vulnerability information, and also give you actionable remediation advice so you can very easily take the right action for you and remediate the issue in a pretty painless and effortless manner. Combined with the fact that you get continuous monitoring, you can catch those issues very early in the process and then replace or patch them while they are still not heavily embedded in your own software, so as to make it easy. And at this point, I would like to say that generally, if you are looking at your software application security as a whole, then you would need to look at both the issues with your open source components and the proprietary code that your own developers are working on. And the best way, the best approach to do that is to look at them together. Because when you look at them together, then it's easier to prioritize your resource allocation and your attention span and make sure that you are investing your developers' time in an intelligent way that will give you an optimized results in terms of both the state of the security of your software as a whole and the amount of work that's required to get there. So I would like to thank you very much for your attendance and your attention so far. And at this point, would like to hand the session over to Matt to take it over from here.
Great, Rami. Thank you so much for the insightful and very educational presentation. I'm going to put on the video. And Matt, are you here?
Paul, this is Matt. Can you just give me control for 1 second? I just wanted to go over a couple things first.
Absolutely.
Share deck.
There you go. Should be bringing up your screen in just a moment. Here we go.
There you go. Can you see the screen, Paul?
Yep.
So, thank you very much, Rami. I appreciate your session, and I wanted to kind of build on your session, talking about the need for looking at application security or your applications and the components of those applications in kind of a must-have type of situation. Homegrown code and open source code are part of pretty much every commercial application. And we really at Checkmarx focus on a secure software development lifecycle, ingraining into the day-to-day activities of the development. People ask me all the time, well, what does Checkmarx do? And what I usually respond is we really help organizations transform their SDLC into a secure SDLC so they can, in fact, push left and scan earlier, scan off, and integrate at every phase of their SDLC without really changing their existing methodologies or practices for their development of software. What actually matters in application security testing, there's a lot of different things that really kind of pop up, but integration throughout every phase is really important. And I really wanted to highlight on this slide and kind of build on what Rami said is there is pushing left, and there's different components and technologies at every phase of a software development lifecycle. And ensuring that your homegrown code and your open source code is secure is paramount for the security of your organization's applications. I like to refer to this as kind of the clock slide or the bubble slide, and it kind of moves through an SDLC where developers proactively scan their code with Checkmarx from Eclipse, Visual Studio, IntelliJ, so on and so forth, so they can interactively get feedback about the code that they're scanning, their homegrown code. They can then actually integrate into their source code repositories and scan their source code repositories, pull the code out. Maybe the code's brought together from multiple development teams in one branch of a source code repository. They can proactively scan and find vulnerabilities there. And then there's the WhiteSource aspect too, where you can actually, in between your build and your scan within Checkmarx, also initiate the open source scanning powered by WhiteSource behind Checkmarx itself. So it gives you that flexibility to scan your homegrown code, and from the same interface also leverage the power of WhiteSource to scan your code as well. And then you can actually move through the process of actually integrating within Checkmarx into your automated builds. And that's represented here by a lot of different build type systems that you could look at, from Bamboo to TeamCity to Jenkins, so on and so forth. So we really do round out the story to integrate from the beginning stages, which is the design phase, maybe the coding phase by developers, through the automation, integrating with the source code repository, ensuring that any open source packages that used in your application are scanned via WhiteSource, and then integrating into the build servers. So when all the code is brought together, you can point out the vulnerabilities. And then this is a mix, wash, repeat type of situation. Just scanning once is not efficient. It's not an effective way to actually ensure your applications are secure. You need to scan, remediate, adjust the code, remediate the code, put in the best fixes within the applications, and then go through a process, especially in a agile CI/CD environment where you have lots of builds, lots of releases happening on an ongoing basis. You want to make sure that you stay ahead of that process. And Checkmarx is, the architecture behind Checkmarx supports that agile CI/CD type of environment with our integration points throughout the software development lifecycle. So that's just kind of one to lay out how Checkmarx fits into this for the homegrown code, and then integrate that into where WhiteSource would fit as well as part of the Checkmarx platform.
Great.
So Paul, you can take the baton back and show the quick video.
Perfect. All right, just give me a moment. Okay, and I'm going to roll.
Okay. So what we're seeing here is Rami showed the actual WhiteSource dashboard. This is the WhiteSource technology, the ability to scan directly integrated into Checkmarx. So your homegrown code, your frameworks, or your libraries, your applications, in addition to your open source code, can be all scanned and initiated from the Checkmarx platform. You can see here we have metrics about what type of vulnerabilities were found within the application or within the open source piece of code that was uploaded. You can see if there's license risk and compliance, outdated libraries, all the aspects of the security for that open source package you've been uploaded. This is really critical in that now you have information about the vulnerabilities in your homegrown code in addition to the vulnerabilities in the open source code. And we know that these two aspects of an application are critical for any security program being effective. So this is just kind of a high level, very similar to what was shown earlier, but now it's actually integrated in the same type of data points, and information and reports are available within the UI of Checkmarx, in addition to WhiteSource. So that was just kind of the view. Paul, you can stop the video.
Great.
Because now we're just getting into a little bit deeper into the Checkmarx solution and the homegrown code. But we really wanted to show that when you have Checkmarx and WhiteSource, you can actually see the data all in one spot, so you can manage your open source vulnerabilities and your homegrown vulnerabilities in one place.
Great. So I want to thank you, Rami, and thank you, Matt. And we're now going to begin answering the questions submitted during today's presentation. As a reminder, you can still submit questions through the question pane in your attendee control panel. And our first question is WhiteSource a full FOSS development lifecycle management solution, or is it primarily a security scanning tool?
Paul?
Yes. Yeah, we can hear you.
Shall
I repeat it?
No, I understand. FOSS normally is pronounced FOSS. It's free open source.
My bad.
It's an acronym. No, that's fine. Yes, WhiteSource does offer a comprehensive management suite for anything that has to do with open source. Security is one very important aspect of that, but we also cover licensing, compliance, quality, versioning, policies, and alerting, workflow management, and so on and so forth. So yes, security is a big part of it, but it's not the exclusive part, and there are many other additional views and issues around open source that we also provide tools to monitor and remediate as necessary.
Okay, great. The next question is, I've advised not to use GitHub as it is often carrying faulty source. So we try and advise NUGET, which seems to be overseen by Microsoft. What do you think about these two sources? Any advice from the experts?
Right, so good news, Microsoft are also switching to GitHub. GitHub as a whole is just a vehicle. On its own, it has nothing to do with the quality or security of the source that is hosted on it. And you should treat each project individually and look at its own metrics for maintenance, quality, security, community strength, and others, which, by the way, WhiteSource can do automation for you. We would know about these GitHub projects and be able to give you metrics about them, so you will know which are the safe and the well-maintained ones, and which are the more dodgy ones that you may want to stay away from.
Okay, great. The next question is, so if I understand correctly, Checkmarx is the management tool and WhiteSource is a scanner that integrates with Checkmarx?
Yeah, would you like me to take that?
I'll give you no.
You can
go ahead. You can take it.
Right, so Checkmarx is also a scanning tool. These are actually two different scanning tools. Checkmarx scans the proprietary code and looks for vulnerable patterns in the code that was written by your developers. And WhiteSource scans the open source components and reports about vulnerabilities in the open source that you are embedding in your software. So these are complementary offerings that together give you a 360-degree view of your application security as a whole.
So, and to take away from there, the real key differentiator too is Checkmarx is primarily a static analysis solution, and we've scanned the uncompiled code. So the code that you have access to, we would be able to scan. We do not scan binary or compiled code. So that's the real difference, is it's homegrown or code that you have from frameworks that you have the source, you can scan with Checkmarx for the vulnerabilities, and WhiteSource actually scans the open source packages that you would use as part of that homegrown application.
Okay, great. The next question is, when you say that most open source vulnerabilities have a remediation, what do you mean and who offers it?
Right. I think the number is 87% of vulnerabilities have a fix or a fix suggestion available to them, and it's offered either by the people who publish and maintain the projects of the community, or by some other, could be vendor or some other community or some other advisory. Sometimes, let's say in the Linux community, it's very common for the developers of various Linux distributions, could be Ubuntu, could be CentOS or Debian, to go and fix vulnerabilities in open source components in the operating system. So it's very different from different scenarios. The more common use case is that the people who release the open source component will then go out and release a newer version with the fix to the security vulnerability in that version. That's the normal behavior that you will see in the market.
Got it. Matt, I believe this question is for you. And the question is, I am a non-engineer in a secure software group using your product for static analysis. My role encompasses BAU process. My question is around updating your software for new vulnerabilities. Can you speak about how you incorporate new vulnerabilities that are addressed both in BAU and emergency processes?
Yeah, so there's really two ways that we can actually address. We do update the intellectual property. If you're familiar with Checkmarx, it's called Checkmarx queries, and we do that on an ongoing basis. We have a dedicated security research team that identifies them. And when a new release or a patch release comes out, when you update the software, you update the queries or the intellectual property behind the product. There is also a way, and this is, some people that are new to Checkmarx may not understand this, but the intellectual property behind Checkmarx is completely open to our customers, and that's very unique in the static analysis world. Some people call the intellectual property rules or checkers. We call them Checkmarx queries. And you can see exactly how we go about finding every vulnerability report. It's in the web UI of what we call the Checkmarx server. And if you want to adjust those for your own code or for a vulnerability that has come out that we don't, have a fix for immediately, you can actually do that by yourself through the Checkmarx auditor, which adjusts the queries. So we are very proactive in updating the intellectual property, but you also have the ability to customize the queries, extend the queries or the intellectual property all by yourself. And that's one of the key benefits that Checkmarx brings to the table in terms of our features and functions.
Okay, great. Rami, this one is for you. If we have an open source JavaScript library, I understand that WhiteSource will inform me about security bugs and license issues. But would it also make sure that the Checkmarx scanner will not scan that source code?
One, your understanding is right. Second, I think that's actually for Matt to say. I don't know how to. Probably there is a way to make sure that the Checkmarx scanner does not cover it, but it's done from within the Checkmarx side of things.
Okay.
Yes, that's correct. When you configure Checkmarx, you can say ignore these files, folders within a project. So if you have homegrown code that doesn't include the source for open source projects, you can say exclude, open source folder, and that would exclude that from the Checkmarx scan of your homegrown code.
Okay, great. And we've got one final question, and that is, why aren't the tools that I'm using to find vulnerabilities in my own code also applicable on open source code?
Right. So I touched on that, but I'll reiterate. It's not that they are not applicable. You can download the open source code and run static analysis on that if you want, but that will not give you all the vulnerabilities that have already been discovered and verified by the community and are published in all of those public repositories and can be exploited by other people who read them. It will just find the same sort of heuristical patterns in the code and tell you where it may be vulnerable or not. There might be some overlap with the known vulnerabilities, but probably not full overlap. And to make matters worse, it would be very difficult to remediate those issues because you will now have to own the code yourself. and version it yourself. You may want to contribute it back to the open source community or not, which will give you some merge issues and so on. It's sort of a different way of handling these vulnerabilities. So WhiteSource would report on the known, publicly available security vulnerabilities in those open source packages and would give you advice on how to remediate them, which is a very good practice when managing open source, is to let the open source community do all that heavy lifting for you. So you don't have to do anything. You just need to take the newer version or some patch. That's it. Rather than downloading the code, running a scan, start at least partially owning the code yourself and publishing code that you yourself now need to write in order to fix those vulnerabilities. And it will start mismatching from the officially released versions, which will advance in their own pace and will not match the version that you have developed on your own, which sort of is a fork of the open source. It just causes a lot of overhead and pain, and is not very scalable, because on average, we know that there are about 300 different open source projects being used in a given commercial software application. So you have to do that 300 times over, which is very expensive, time consuming, and not efficient.
Great.
Yeah, I agree. I 100% agree with that statement in that, you don't want to own the vulnerabilities in the open source package. It's just not something that you would want to undertake. It would be, a COTS-based product that you used off the shelf. Would you want to scan that and fix it if it was provided to you by another third-party piece of software? Let the experts fix the vulnerabilities themselves, the owner of the open source packages, because that's not, again, something you want to get into the business of, because then you own it. And then if you ever want to upgrade to the next release, now you have a mismatch even within your own environment about your custom release of the software and the latest release of that open source package.
Great. Well, I want to thank Rami and Matt and everyone else for attending today's webinar, Open Source Security 101. On behalf of Checkmarx and WhiteSource and both of our presenters, thanks for joining us and have a wonderful day. For more information about how Checkmarx and WhiteSource can help you secure your open source components, please visit checkmarx.com.